This example is asking us to find the antiderivative of this equation here, x cubed times the quantity x to the fourth minus 2 to the ninth. When you look at an antiderivative problem, the great thing about antiderivatives, integrals compared to derivatives, is there's far less rules for you to have to worry about. So really when you look down at the problem, you've got kind of three options. It's either going to be a bunch of things being added and subtracted, which means you're going to run a power rule, or it could be what I call special case antiderivatives, so your trig functions, things like that, your natural logs, stuff that you had to have memorized. And if it's not either of those things, then 99 times out of 100, you're pretty much looking at the only other game in town, which is U-Substitution. And that's what we have going on here. We've got two things being multiplied. We have stuff inside a bunch of parentheses raised to a power. So this is definitely something more than just a power rule. So we'll run our U-Substitution process. U-Sub is a set of side work. It's the same set of side work every single time you do it. So once you get your rhythm down on these and practice it a few times, they're really pretty straightforward problems. So let's get going on it. Step one of a U-Substitution problem is you want to choose the U. When you go to choose your U, I kind of have a priority list that I run myself through every time. So my priority list starts off, and the first thing I go looking for, if it's available to me, is a natural log. If the natural log isn't in the problem, then the second thing I would look for is what I would call the inside piece. Similar to when you were taking a chain rule, something that's inside another function, inside a set of parentheses. And then the third thing, if neither of those are there, is I go looking for the bottom of a fraction. Generally, sort of an overall rule you kind of want to be looking out for is usually you want to be looking for the piece that has the highest power of x. That's usually going to help you also find what you're looking for. So in this situation, I start off with looking for the natural log. I don't see that over there, so that's not going to be what I want. Then I go to the second option, which is the inside piece. And I do have an inside piece. This x to the fourth minus 2 is inside that power of 9. It also is the piece that has my highest power of x, so it's doing a lot of things that I like, so that's going to be my u. So u is x to the fourth minus 2. Once you've selected your u, the second step of the process is to find the derivative. So in this situation, I do du dx, and I always want to use that derivative notation when I'm doing u substitution. And I work through the derivative of this equation following my power rule. So I bring the power down, subtract 1 from the power, and then the derivative of negative 2 drops off. The derivative of a constant is 0. Then the next part of my process that I need to do is when we go to substitute into our original equation, we need that original equation to be talking nothing but the language of u. And that includes changing out that dx to become a du. To do that, what you're going to want to do is you're just going to want to solve that derivative equation you just found and get dx by itself. So treat dx like any other variable and get it alone. So the first thing I would do is multiply both sides by dx to get it off the bottom on the left there. That would give me du equals 4x to the third dx. And again, I'm just solving for dx right now, so I would divide both sides by 4x to the third to cancel that out on the right-hand side. And I end up with du over 4x to the third equals dx. So now I'm ready to substitute. I'm going to take that and I'm going to substitute u for it, and I'm going to take this and substitute for dx. The way you work this is just work your way left to right through that original integral. And it's either one of the things you're substituting for, or it gets left alone for the time being. So working through this, I have my integral symbol. Nothing happened to that x to the third. All this stuff inside here, that is my u. So this is now u to the ninth. And dx becomes du over 4x to the third. At this point in the process, any x's that were left in the equation should ideally cancel out with x's that I just plugged in. Because remember, we're trying to get this whole thing to talk nothing but the language of u. And what you can see is I've got an x to the third up top here and an x to the third on bottom. So those two things are going to cancel each other out. As I come to now simplify what I've got and rewrite this, you're going to notice that you've got this 4 down on the bottom. That's really, there's an unwritten 1 on top here. So that's really a 1/4, and I'm going to slide that 1/4 to the front. So I'm looking at 1/4 u to the ninth, and then I've got my du at the end. And this right here, this is what I call your reward. This is your reward for all your hard work. You've got a brand new math problem. And so what you do now is ideally you have taken your antiderivative, your integral, from something you didn't know how to do to turn it into something you do know how to do. So at this point, this should either be one of our power rules or one of those special case antiderivatives that you just have to have memorized. And what we can see here is that we're looking at a pretty straightforward power rule. So the power rule saying that I use is step 1, you're going to add 1 to the power. And then step 2, you divide by the new power. So applying that here, I would add 1 to my power. So the 1/4, the constant up front, comes along for the ride. I add 1 to the power, that gets me u to the 10th. And then I divide by that new power. And then we always put that plus c at the end when we don't have any bounds on our antiderivative. The last move really here is now you didn't care about u. You really cared about what u was. And so now what you want to do is substitute back in your u into the equation. So we'd end up with 1/4, and then instead of u, I pop back in what u was, x to the 4th minus 2, raise that to the 10th over 10 plus c. And then you'd look at your answers and you would see that they want you to do just a slight bit more of simplification. And really all we can do is we can sort of multiply the bottom of our fraction together here. So this ends up becoming x to the 4th minus 2 to the 10th over 40 plus c. And that's going to be our final answer on this problem. And as we go back up and look at our answers, that matches up perfectly with answer C. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.